Hello everyone, welcome back to Math with Allison. Today we're working in our sequences and series and we're going to be talking about the comparison test. So this is different from the limit comparison test. They're two different tests. I'm going to do that one next, but for now we're just doing the comparison. So this is where we are comparing two series. So let's say we have one series A sub k and we have another series B sub k. All of these need to have positive terms in order for you to use a comparison test. So first we have if the terms A sub k are all smaller than B sub k, and we know that the series B sub k converges, then that means the series of A sub k is going to converge. So here we have all of the terms are smaller, right? Which means that the series A sub k is smaller. So another way to write that is the series of A sub k is less than or equal to the series of B sub k. But we know B sub k converges, so let's just say this is equal to some number B, right? That's what it converges to. Well, that tells us our series A sub k is less than or equal to some number B. So if our series of B sub k's converges, then obviously our series of A sub k is also going to converge. Now we can do the same thing with divergence. We just have to switch it up a little bit. So here we have if the B sub k terms are all less than or equal to A sub k, that would mean that we have that B sub k is less than or equal to the series of A sub k, right? And if B sub k diverges, so let's say it diverges to infinity, then that means our series with A sub k is also going to diverge, right? That tells us that this series is greater than or equal to infinity. And what's greater than infinity? Infinity, right? So that is the comparison test. If we take a look at this example right here, we have the series k equals 1 to infinity of 1 over k squared plus 2k plus 7. So very often, I'm not saying all the time, but it is very common to use the p-series test to compare. So what I see when I look at this series is we have k to the power of 2 in the denominator. So what I'm going to go ahead and compare that to is the summation k equals 1 to infinity of 1 over k squared, because I know I can use the p-series test, right? So the question is, how do we find which one's bigger or smaller? And I always do that by just comparing the two values. So I'm going to plug in k is equal to 1. So for our first series, we get 1 over 1 plus 2 plus 7, which is equal to 10. And then for 1 over k squared, that's just going to be 1 over 1, so we just get 1, right? So here, just plugging in one number, you can tell which one's going to be smaller, right? But you can plug in multiple just to make sure. So if we plug in 2, we get, that's going to be 2 squared plus 2 times 2 plus 7. 4 plus 4 plus 7, that's going to be equal to 15. So 1 over 15. And then here, we're going to get 1 over 4. Again, you can see what's smaller. I'm going to do one more, k equal to 3. So we get 1 over, and let's plug that in. So 3 squared is a 9 plus 6 plus 7. That is equal to 15 plus 7, which is equal to 22, right? So 1 over 22 compared to 1 over 9. So I took a couple just to make sure we knew which one was smaller, right? So we have our original series is going to be less than this new series that we're comparing, right? So let's look at our new series. We have that using the p-series test, p is going to be equal to 2. So this series is going to converge using the p-series test, right? Say it to some value a. So here we have our original series is going to be less than our series, our p-series, right? And this is going to be equal to some value a. That tells us that our series is going to be less than this value of a, which tells us that using the comparison test, our series, which we have right here, is also going to converge because it's less than some value a, right? It's not going to grow infinite. So there is our solution. Let's go ahead and try another one. Here we have the series k cubed over 2k to the power of 4 minus 1. So notice what we have here. As k grows really, really large, this is just going to behave like the summation of k equals 1 to infinity over k cubed over 2k to the power of 4, right? When you're subtracting 1 from a super large number, it's not going to make much of a difference, right? And this we can simplify down to k equals 1 to infinity of 1 over 2 to the power of k, right? So that's another strategy you can use. You can try just taking the highest power of the numerator and the highest power of the denominator, right? So let's go ahead and compare these. I want to go ahead and see which one's smaller and which one's larger, right? So we're going to plug in some test values. So first we're going to get 1 over, that's going to be 2 minus 1, which is equal to 1. 1 divided by 1 is just equal to 1. And then over here, we're going to go ahead and get 1/2. So notice which series is smaller this time. You can plug in a couple more just to make sure you did the math right? And again, we have 27 over 161 is bigger than 1/6, right? So here we know which series is larger and which one's smaller. So we have our new series, the summation k equals 1 to infinity of 1 over 2k is going to be less than our original series, right? So we have the summation of 1 over 2k is equal to 1/2 the summation of 1 over k. And we know what that series is, right? That's a harmonic series. And we know what the harmonic series does, right? The harmonic series diverges to infinity, right? So if I replace this series right here, we know that this is going to diverge to infinity. And we also know that this is smaller than our original series. So that tells us our original series is greater than infinity. And again, what's greater than infinity? Infinity. So that tells us that this is going to diverge. We have one more here. And what I'm going to do is I'm going to compare this to k equals 1 to infinity of, and I'm just going to take my largest power of k, right? So I take out that plus 2 because when k is really large, adding 2 is not going to make much of a difference. So here we can rewrite this as k equals 1 to infinity, and that's going to be 1 over k to the 3 halves. So here I want to see which one's larger and which one's smaller. So I'm going to go ahead and plug in k is equal to 1. Right here I get 1 over, and that's going to be the square root of 3. Over here I get 1 over 1, which is equal to 1. So that's easy to compare to 1, right? So I'm going to have this inequality right here. Our original series is going to be smaller than that one. So let's go ahead and use the p-series test on this. We have that p is equal to 3 halves, which is greater than 1. So by the p-series test, this is going to converge. Now let's take a look at the comparison test, right? And so that tells us that our original series is going to converge as well, right? So that is all I have for us in this video today. If you enjoyed it, I have many more like it, so make sure to check out my playlist or link down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.